Hey Jackal! In one of my latest videos, I showed you how to make this game. It's a basic timer game. The goal of it, to stop the time at something seconds with 00 at the end. To make the experience better, I wanted to use a big button like this one, and that's exactly what I've done. If you want to know how I've done this big button, you can visit my other channel, Jackal DIY and Tech, where basically what it does is it has some idle animations, it has 4 idle animations, breathing, it then goes from these 2 sides and moves down. This one just goes from this side to the end and then back. And last one, it's twinkling in different colors. And lastly, when you press the big button, it simulates a space key press and it also has its own animation. Now in this case, the animation doesn't go well with this game because I have hard-coded the animation length, so while the animation is happening, you cannot press it again. And that is why I actually made a different game that replaces this basic timer. So let's take a quick look at it. So we have 4 different fuses that are selected randomly. When you press the start button, we get a countdown timer.
What are you going to do?
And the goal is to try to get to the smaller point on point. The videos at the moment are just placeholders. I'll replace them with something else, but this is the concept for this simple game. So this was made in Unity. It works perfectly fine on PCs, but I did have some issues on an Android tablet. I didn't test it on other Android devices, but on the tablet, which is a Samsung Galaxy A8, and I believe it's from 2010-21, and that tablet has like a half a second delay for some reason, and I did not find any fix to it. At least not an obvious one.
I told you to be quick, and this is why. You waited too long. Now it's gone up in flames. Nice! You saved the day with that perfect trigger.
Now how I have actually done the game. The game is made out of a bunch of images, texts, and in this case 2 buttons. As for the interesting part, it's the ball and the graphs. The ball follows the graph line by using invisible points, and I know I could have used splines, but those just did not seem to work. I think that will be it for this section. In the next section we'll go into the code and Unity and see how this is actually done. So let me walk you through and explain how I got to this version of the game, which is final one, and we all know it's never final. But before we take a look at all of the elements that I have used, the initial idea was that the user will just press a button, ideally a space if using a keyboard, and this would be done on an Android tablet. So that is why I have made a big button, which you can watch on my other channel. And having a big physical button just makes the game experience that much better and satisfying because it has all of the LEDs. So the initial idea was for the game to be used in exhibitions. We just wanted one fuse characteristic graph and that's it. Now because nothing was set in stone and each person has different ideas, we ended up with 4 different graphs, some fun elements of the electrician popping up if you trigger the fuse too soon, just at the right time or too late, and also educational elements which the illustration covers. Each different graph is linked to a different fuse, and I think that's about it. So that was the build done for Android tablet, but they also got the idea to make this into a PC build, which is, well, basically the same. It just runs better on PC. And lastly, they wanted a build for web. So that is why I added a tiny button, and now the instructions open at the beginning, so you can read and see what you have to do. And once you close, you can either click on the button or press space.
Great job. You've got the hang of it now.
And every time a video plays, based on when you trigger the fuse, and also different text is displayed. Now when it comes to the voices and the lines, I think I added 5 different elements for each. And the quit, while nothing happens in Unity editor, the application does quit if on PC or Android, when on web it opens the company website. But in any case, let's jump into Unity and take a look at the inspector. So I have the camera, I have not done anything special to this, and this is a 2D project made in Unity 6. Why Unity 6? Well, I just wanted to test it out. So now let's take a look at the elements. The biggest one, I would say, is the game manager. Everything happens in this one. And I am not saying that this is the best solution to just stack everything to one game object, but in this simple game, I think it is okay. So first we have graph variations. We have 4 of them. Each has a minimum and maximum amperage. So the starting and the ending value, and the blow amperage is basically the point that you want to achieve when triggering the fuse. And then we have path points. Each graph has a bunch of different points. So if I open, this is maybe graph 1. So it has 13 points. If I enable them, you can see how they go. And previously the breakpoint was this one, point 10, which I don't think is currently the case. It is not, it is 0.6. Which in the scene view is this one. And I would have to hide the graphs for you to see the correct one, which is this one. So basically, every graph is made out of a bunch of points that I've manually adjusted, and then the main point that travels along the graph basically travels between the points. And basically, only the point that is the trigger point is visible and the others are hidden. And this is true for all of the graphs, as you can see. So that is how the graph variations are done. Similarly to graph images, I have already shown you the images. So these are the graph images. They are disabled or enabled based on which graph is selected, and that is selected randomly when we press the button. The same goes for the graph fuse images. This is the fuse, and I also included this text to be a part of the whole image. And lastly, we have the graph paths, and each path has different number of points. As you can see, just between these two, the first one has less points than the second one. So this covers everything that has to do with the graphs and displays. Could this be implemented in a better way? Most likely, but at the moment this does its job and it's fine. Now each graph, as you can see, has dotted lines. This means how big the tolerance is, and this is represented by this value that is used in calculation when triggering the fuse. Then I have the time scale factor and the initial wait time. So this is the countdown timer. The time scale factor is how fast the graph will actually go, or not the graph, the ball. So let me go to play focused. So we can test it out. If I change this to 2.
You waited too long. Now it's gone up in flames.
You saw how fast the ball went. If I use 0.1, you can see how fast the ball goes. And also the ball starts slow at the top and gets faster the longer it travels.
It's over. The fire's spreading and there's nothing I can do.
So maybe 0.5.
Seriously? You had one job and now I have to fix it.
Maybe something between 0.5 and 1 is a good value to use.
You jumped the gun. Now I've got to fix your mistake.
Then we have the point visibility delay. Now this just stayed in, but the initial idea was that we did not have any breaking point indicators, so the user would actually have to check and look at the graph and kind of eyeball where they would actually have to break the fuse. And because of that, the ball would not initially be shown at the top. Then we have 2 buttons, the big button on the bottom, the exit button on the top, the menu open button and menu close button, which is what I have added for the web version, which is this one. So this is the menu open, and then we have the menu close button. And I have also added a nice animation to that. Then we have the point sphere, which is basically a sphere with 2 particles attached to it. And we have the canvas for videos. So maybe I can touch on this a little bit. So this was the first time that I have actually used the video in a game. So to add one, you simply right click, go to video and add the video player, which is this one. The source is set to video clip and the actual video that you want to play. So it is an MP4 file and I used Handbrake with the baseline profile. Otherwise, Unity complained that something is mismatched, but it did play anyway. Now the only thing that you have to take note of is the target texture. You do need some kind of texture where you want this video to actually be displayed. So if I click on it, this is it. So you have to right click where you want to create this video texture. So create, we have rendering and render texture. That is correct. So you have to set the size. So I have set it to 1088 by 832, which is what the original videos were. And everything else can be left as is. I have adjusted the scale of this raw video image.
You waited too long. Now it's gone up in flames. I told you to be quick, and this is why.
So as you can see, you do need both elements. You need the video player that takes in the video rendered texture, which is this one. And this one is the raw image. So basically I right clicked, UI, raw image. And this one too takes the video rendered texture. So both of them take the video rendered texture that you make. And for some reason you do need both of them for the video to actually show up. Now that's all fine. And it does work on Android and obviously PC. But when it comes to web, you can't use the same one. Well, you can use the same video player, except you have to specify the source, not as a video clip, but as a URL. So I have done that. I specified the video, but for some reason, the videos did not play in the web version. So I will leave a link to this game, which is running on the company server if you want to test it out.
You jumped the gun. Now I've got to fix your mistake.
But as you can see, in this version of the game, I do not have any videos. I just have images. because when using videos, everything was black. Why that was the case, I have absolutely no idea. So when using the web version, I actually just use the images instead of videos. So even though I have this enabled, when building the web version, the images were used because for some reason the videos just don't play. Now for the most part everything was working nicely, and obviously did if making a game on the PC, but when I then finally made the build and used it on the Android tablet, the game was lagging by maybe half a second. When I used the profiler under the analysis, but this is on the PC, so this is very fast and I should not have any issues.
Great. Now we're going to be here all day.
So everything is basically buttery smooth, as you can see. Maybe an occasional spike, but nothing drastic. On the tablet though, the CPU and GPU were in red, both of them between 20 to 30 milliseconds, which made the game unplayable. I did try a lot of solutions, also refactoring the code on how the dot moves along the line, which overall did not make any difference when it comes to the lagginess. It did improve the game overall, but not when it comes to the lagginess. What did fix it though is by me setting the FPS target to 120 frames. It for some reason fixed the issue. Now when it comes to the code, I just have two scripts. So one of the scripts is the public float amperage point. So each point has this script, so I can set an amperage value to it. These are points, and I can set the amperage values. And these are the values that we use between 2 points, so we can deduct what the value was when the fuse has been triggered. As for the game manager, let me open it up. So we have a public class, graph data. Each graph takes a minimum amperage, maximum amperage value, below amperage value, and a transform list of paths, or the path points. The game manager itself though, so let's see, we have a bunch of lists. So this is for all of the graphs, and this is the tolerance, 5%, that we could also adjust. Then we have the buttons, and the time scale that I have showed you, the timer, this was set to 3 seconds, and the point visibility, this is the point that we are moving. Then we have some texts, success, the amperage text, so the value, the bit amp text, which is set at the top, and the countdown timer text. I also added some audio because every game needs some audio, and we have the video clips and the fallback video images. The animator is just one because I use it for the menu, and I also have access to the game object of the menu canvas so that I can hide it and show it. As you can see, this is the solution that I came up with. So target frame rate, set it to 120, for some reason this works. If I set it to 60 or even 30, the game was lagging. So I have exit button on click, exit game function. Exit game function is this one. If it is on web, it goes to this website. If it is not on the web, so Android or PC, it quits. Then the menu canvas at the beginning is set to active, so it is visible when we start the game. This is mainly for the people that play on the web. Previously I had this set to false, and it then did not make any sense to the players, and the easiest fix was to actually show the instructions at the beginning. I then set everything to false, so graph paths, the video clips, the fallback images, everything is set to false, so that I only enable the components that I actually need to enable. And then we have, if the game is running, we move the point along the path, and before the game can run, we need to somehow start it, so we have this toggle game, which is down here, we check the condition, so we know if we can actually run the game or not. So if it is running, we trigger the fuse blow, and if it is not, we start the game. So we set the graph point game object to false, and we start the coroutine of this one. So start game coroutine. At this point, I disable the button, so you cannot interact with it again, so you don't accidentally or intentionally start the game a bunch of times. We then select which graph and everything that has to do with that specific graph gets enabled. So this is what the pre-calculated graph data does. I then also set everything to false when it comes to the video and the images. And basically what I have done is, I think this one is for the burning. If we fail, this one is if we're too soon on the trigger, and this one is if we are perfect with the trigger. Here we set the graph images, the fuse image, and the graph paths. And then we can actually start displaying something. So this one displays the top text, at how much amperage you ideally want to trigger the fuse, and this changes the text of the button to trigger fuse from start. This is a simple countdown timer that also plays a sound on each second. How do we know it's on each second? Because we have here wait for 1 second. With this line we get the current amperage and we start the time. And then we basically have the trigger blow. So we started the coroutine and now we have to check when it stops. So I have here a sure delay. Let's see what I've done with this one. I forgot a bit. So basically it just changes the text on the button. So it changes this text. So first is triggered fuse. Once we trigger it
too soon,
we
didn't
have
you?
loading and it goes to start. So this is what this function does. Now we have a bunch of math and then we have the success roll. I guess I use just 3 texts for each success, or let's call it fail, but you could add to this list and implemented it in a better way. I think this is good enough as is. So every time you stop, and depending on what it is, if it's perfect, one of these 3 will be displayed. If it's too early, one of these 3 will be displayed, and if it is total collapse, total fail, one of these 3 will be displayed. What about the sound? Well, as you can see, I have here a list. So burning sound is a list, at least it should be. So we do have a list of audio clips and it goes from 0 to the length. So basically how many we have put in. And I think I have 5 audio sounds put in. So in the burning sound, yep, I have 5 audios for that one, for this one, and that one. So 15 sounds in total. And in this case, I specified 2F for the burning sound because it was a little bit too quiet. For other ones, this one as well. Oh, and this one as well. Okay. As for the audio source and the volume, the master volume is set to 0.2. And this is something that I had to do because otherwise the audio was too loud, especially when it comes to the sound effects of the ball moving. And now the 2 functions were methods that are actually the most important to this game. One is the pre-calculate graph data. Previously, I've done all of this inside the update method, which was costly, but still on the PC it did not make any difference, and also on the Android tablet this did not affect the lagginess, but still this refactoring is a lot better than just running this inside the update method. And then the actual moving of the point. I'm not gonna lie, I did not came up with the math myself. I had a lot of help with using ChatGPT and other tools that actually understood what I wanted to do. So this is the final working result. Could I have done it any better? Probably, especially if I knew how to use splines, I would say. maybe using splines would actually be the best solution. And lastly, I have 3 functions for the basically menu. I think this actually gave me the most problem. Playing the simple animation, for some reason this just did not want to play nicely, but now it does, so it's all good. Now I'm definitely not the best when it comes to implementing the animations just yet. This is what my animator looks like. I had to make a separate idle animation. It did not seem to work if I just had one of them and playing them in reverse when a certain condition was met. So if I enable the instruction menu, it's what it should say, and play the open animation. This is how that looks like. I then wanted to play this animation in reverse, no such luck. So I made a closing animation, which is basically the same as this one, only played in reverse, but still switching between the two, no such luck. So I actually had to make an idle animation, which is basically the menu closed. As you can see, the Y scale is set to 0. And then the animation worked as intended. I think this will be it for the video. I do encourage you to try out the game. I will leave a link down below. And if you do, let me know if you use the button with the mouse or if you use the space key, and which of the two was easier for you. And also, what was the closest that you got to triggering the fuse at just the right time. If you enjoyed the video and would like to see more content like this, subscribe to the channel. I'm Simon, and until next time, Jackal, keep it digital.